Hello everyone, my name is Shrisha. I am from CSC AIML department of section B. Today my EPS topic is pattern matching. So what is pattern matching? Pattern matching is the process of checking whether a given text string, data or symbols contain a specific pattern contains a specific pattern. It is widely used in programming languages, text searching, data filtering, compiler design, artificial intelligence, and regular expressions. So, let us move on one by one. So, how this pattern matching helps in programming languages? Um, Programming languages. Like pattern matching allows programs to identify structures easily. It is used in languages like Python, Scala, Haskell, Java, etc. It helps in matching specific data, shapes, conditions, and values. It makes code shorter, cleaner, and easier to read. And we have an example that is matching different cases in switch, match, or statements, if else statements. Next, we have text searching. Pattern matching helps search of specific words, symmetric patterns inside the text. It used in search engines, editors, file search tools. It can find emails, datas, dates, names, keywords automatically. We have an example that is searching for all mobile numbers in a document like that. And next we have data filtering. So pattern matching allows us to filter only the required data rules. This we all experience this data filtering, that if we want any particular matching thing, just we'll search and then we'll sort out the thing. That is known as data filtering. So it used in data processing, databases, Excel filters, and log arithmetics. And also it helps in selecting items that match specific criteria. Just now I have given an example. So one example is filtering all records where names start with A. If we have a set of names, then just filtering or sorting out a name starts with A or any specific uppercase material. And next we have compiler design. So compilers use pattern matching to recognize patterns code. It helps in tokenizing, parsing, and syntax analysis. It detects keywords, operators, identifies numbers. We have an example here. So matching pattern like we have two, identifier and number. We have identifier like we have square brackets with lowercase a to z letters and uppercase a to z letters, and we are matching here with a to uppercase a, z to number 9. So here we have numbers and with incrementing of plus 0 to 9. Now, let us move on to the types of pattern matching. So, similarly, there are three types of pattern matching. There are exact pattern matching, approximate, also known as fuzzy pattern matching, and regular expression, also called as regex pattern matching. So, these are the three types. So, first one is exact pattern matching. It finds the pattern exactly as it is. Example, if we have a string x y z a b c z y, and if we want to sort out string a b c from this, then it allows if it is possible in the given string, then it searches out in it will give the input abc. And another example, if we have a database, the group of roll numbers, and we want only a particular roll number, just we will sort out and it will give. It is also a simple basic example for exact pattern matching. And next, we are going to approximate pattern matching. It allows mismatches, uh, useful in errors useful in. Like mismatch is nothing but if there is any syntax error, no problem, it just allows. So example we have in DNA sequence search, in autocorrect in mobile phones, in spell checking, speech recognition. Oh, so these all are some application baselines. So these are the approximate fuzzy pattern matching. We have an example, searching color. So we all know that the color COLOUR, but also it accepts the spelling COLOR. So this is the difference between fuzzy pattern and exact pattern matching, where the exact pattern matching won't allow COLOR spelling. And next we have regular expression pattern matching. It is, we can consider it as an advanced pattern matching using special symbols. Example, we have here our uppercase A to Z elements and with lowercase A to Z elements with plus as a plus a dollar. This implies it checks if a number starts with capital letter or not. And another we have with 0 to 9 and with the flower base 10, it indicates that it matches a 10-digit phone number. And next we have compare simple but slow time complexity. It have so here's there are two statements that n is equals to text length, two parameters, n is equals to text length and m is equals to pattern length. So let us know what they are. First, just steps. Align pattern at the start of text. Compare characters. If mismatch, shift by one. Repeat. This is a simple code for that. So now let us discuss about algorithms. We have some algorithms on this pattern matching. So first one is KMP algorithm, also known as Cut-Morris Plat. So it avoids rechecking characters, uses a preprocessing table called LPS, and faster than name, time complexity. It is also used in search engines, bioinformatics, compiler design. And next we have Boyer-Moore algorithm. It compares pattern from right to left. It uses bad character rule and good suffix rule. It is very fast in practice. And also it best for large text, multi-word searches. And we have Rabin-Karp algorithm. It uses in hashing to compare patterns, good for multiple pattern matching. And we have an example that finding many keywords at once. So time complexity, average of 0 n plus n and was 0 of nm. So we know what are the n and m parameters. Just in the previous slide we have saw it. So here n is nothing but text length and m is nothing but pattern length. And next we have some applications of pattern matching. Still now we have saw about the algorithms. Now we will see the applications of pattern matching. The first one is search operations. So search operations means finding words in document, searching records in databases. These all are comes under search operations. And second we have data validation. Check format of email, password, phone number using regex pattern matching method. And next we have compiler design, tokenization, identifying keywords and operators. And fourth, bioinformatics. Bioinformatics is nothing but dealing with the biology like DNA or medical any scanning system like that. So here also it is one of the application of pattern matching. The main important pattern matching plays a key role in DNA sequence matching. So connecting DNA. And next we have text editors. It find and replace autocorrect spell check. And sixth we have AI and machine learning. So this is also one of the most important application we can say. And now we'll see the differences between pattern matching and pattern recognition. So pattern matching works with text or symbolic data, where the recognition works with images, speed, signals. Pattern matching usually extract or rule based. Example, reject search. Whereas pattern recognition, learning based ML or AML, example face recognition like that. So till now we have discussed many things. So first we have read what is pattern matching. Pattern matching is finding patterns in text data, and we have saw types. There are three types: exact pattern matching, approximate pattern matching, and rejects pattern matching. And next we have saw algo. We have discussed about algorithms. So we have discussed about five algorithms. There are naive algorithm, KNP algorithm, Boyer-Mori algorithm, Rabin-Cab algorithm. And next we have discussed about applications like search, validation, compilers, DNA matching processing, etc. Now, just let us see the images, how the pattern matching works. So these are some examples of pattern matching, pattern search, pattern search algorithm, and pattern matching problems. So thank you.